So my background is that I've mostly been in testing-focused roles so far. And I used to think that, if only we had more time for testing, we'd eventually find all of the bugs. But I started noticing that most of the escape defects I could remember were things that I really never would have found, or things that I couldn't have prevented anyways. So while good testing will always be important, rather than investing in truly excellent testing, I'd rather assume that things will go wrong and just be prepared to handle that. So what is the difference between good and excellent testing anyways? To me, excellent testing is thinking of as many test cases as you can, trying your best to run them all, and continuing to test until you basically run out of time. On the other hand, good testing still involves thinking of as many tests as you can, but then choosing to only run the ones that you feel will give you the most information about how well your product is working. And then spend your remaining time planning for how you'll detect and resolve all those failures that you weren't able to anticipate. So I work for a company called D2L. If you go to University of Waterloo, you might be familiar with our software. We're located here in Kitchener, Ontario, and we make a learning platform called Brightspace. So the stories that I'm going to tell you today in this presentation are about my work on Brightspace. So I'll start with 3 examples of things that have happened to me that made me realize I was always going to miss bugs, no matter how much time or money or people that I had for testing. The first story is called Monitoring User Really Loves the Homepage. So my team was making a report to help school administrators better understand which of the tools within the learning platform were actually being used by their students and teachers. And so this is what the report generally should look like, and this is what it looked like during our testing. Now this is what it actually looked like after we deployed it to production. As you can see, almost the entire graph is taken up with this one slice of the pie that represents the home pages tool. So why was this? What happened? It turns out that each school has an automated monitoring user that hits the homepage tool once every 5 minutes to make sure their site is up. I had no idea that there was such thing as a monitoring user when I started working on this. So anyway, we changed our report to exclude data from this particular user in every system. But so you don't know what you don't know, right? Monitoring users don't exist in our test environments, and I didn't know they were a thing in production. So I really had no chance of ever connecting the dots that maybe monitoring activity was going to completely overwhelm our pie chart and make it basically useless for anyone who wanted to actually use it. And even if I did know about monitoring users, I'm still not entirely sure that I would have made that connection and thought to test for it. So story 2 is called The Port That Was Closed for No Reason. This time, my team was developing a new service, and it needed to have a dedicated port in each of the data centers where we host Brightspace. So we asked the data center administrators for a port that we could use, and they assigned us one. We'll call it port X. And it was open in all of the data centers and not being used for anything, so great. And all of our testing worked great in the test environments, and so we decided to start rolling our service out in production. So we deployed in one data center and another, thumbs up, green, everything good. And then suddenly, disaster. None of the Brightspace instances in one particular data center could connect to our new service. So why? What's going on here? What's with this one data center? So after some investigation, it turned out, well, port X was actually closed in that data center. But it was open last time we checked. So we reopened it, and Everything was fine in that data center too. And the lesson here is that no matter how well you test and research and prepare today, something could always change that makes your results and conclusions completely invalid tomorrow. Story 3 is called... You guys are laughing because you know what I'm talking about here. So yeah, S3 will never go down, right? And so in this story, my team was building a product that relied heavily on S3, Amazon's simple storage service. And now S3 has a really long track record of extremely high availability. And so many people are relying on this service these days. Like, it must be a pretty safe thing to use, right? We consciously decided in this case that we weren't going to worry too much about building and testing contingency plans for how our app would behave if S3 ever were unavailable. And so yeah, you can probably tell where this is going, right? February 28th last year was kind of an awkward day in my team. Amazon S3 did go down, and it was down for many hours. During that time, our users were just unable to use most of the functionality in our application. And the worst part of it was the feeling that there was really nothing we could do at that point. We just kind of hoped Amazon would get S3 back up soon. So no matter how well you've tested your stuff, if one of your dependencies is down or unavailable and you don't have a backup plan, your users might still be out of luck. And so in this case, we knew that we had a dependency on S3, but it's also very possible to be impacted by dependencies that you're not aware of. And nothing is invincible, not even Amazon S3. So those were some stories of bugs that I've missed that I don't think could have been prevented by additional testing. Next, I'll tell you 2 stories about how investing in monitoring and rollback strategies instead of exhaustively testing everything we could think of before release have really paid off. First story in this section is called the off by 10,000 error. In this case, my team was developing an event messaging service, and it required all instances of our product to maintain connectivity to a message broker in AWS. And in order to keep these connections alive, we configured each instance to ping the broker once every 10 minutes. All messages sent to or from the broker, including the ping messages, cost money. I mean, like a tiny fraction of a cent, but still something. And so because we had a budget to stick to, we put some monitoring in place using Amazon's CloudWatch that would notify us if we spent over a certain amount of money in a particular month. So one day, we hadn't even rolled the service out to production yet, and our alarm went off. So we looked at our daily cost data, and it was clear that something was running up the bill, but what was it? We didn't even have the service in production yet. So next we looked at data we're collecting about our event messages. And something was weird here too. The proportions were all out of whack. I mean, 99% of all messages shouldn't be those ping messages. So this ultimately led us to discover a typo in our code that meant we were actually sending ping messages once every 1 second rather than once every 10 minutes. There was no functional impact to the event messaging service when the ping frequency was incorrect, even by that large of an amount. So without cost monitoring and the message type telemetry data that we had, it might have taken us a really long time to even notice the issue, much less troubleshoot it. And in the meantime, we would have been wasting a lot of money and causing a lot of unnecessary traffic on our network, both of which are things we generally like to avoid. So the thing I learned here is that working fine doesn't necessarily mean you don't have problems. And now the last story is about the calmest production failure ever. So feature flags are a great way to manage risk in software projects. The basic idea is that you can separate the concept of deploying code and actually having it take effect in production. So you can deploy a new feature, its code is in the build that goes to production, But then you can use a feature flag to keep it turned off until you're ready to turn it on at a later date. And just as importantly, it also gives you the power to turn a feature back off once it has been turned on. And all of this without having to deploy a new build. At D2L, we're using a tool called Launch Darkly to manage our feature flags. For the event messaging service I was talking about in the last story, we set up a feature flag that looks like this. It's so that we could slowly roll out more of its functionality over time as we gained confidence in its ability to fully replicate the legacy functionality that we wanted it to replace. So one day, all of the health checks for our production service suddenly started failing. Because we were operating in a mode at that time where both the old and new messaging methods were running in parallel, we knew that any failures in our new service didn't mean we were losing data, and really there was no negative impact to the customers at all. But these failing health check notifications were getting kind of annoying though, so temporarily we reverted to a state where the new service was completely inactive so we could investigate further. After we resolved the issue, and actually it was nothing to do with our service, we switched back into that parallel mode where both old and new versions of the service were active, and everything was fine again. Later that week, we decided we were ready to take the next steps and moved into a state where only the new service was active, and this meant that our new feature was completely rolled out. All of the things I just said happened without us deploying a new build. Just think about that for a second. At every moment when the production service was down, we were just one click in a web UI away from safely reverting all the customers to the old version of the service. So not only does that mean we can fix the problem really quickly, but because we're not freaking out, it also means we have the luxury of staying calm and thinking clearly about what our next steps should be. And this is probably the most valuable thing you could have during an emergency. In fact, it kind of removes the concept of emergency from your team altogether. So hopefully by now you're thinking, this all sounds great, but how would I get started with doing that in my own team? So the first step, not surprisingly, is do good testing. So test until you feel pretty confident. But don't bother with tests that are so artificial that they're probably not telling you very much about what might happen in the real world. I'd say also skip tests that are so expensive or time-consuming to run that it's kind of hard to justify them. And if you already know you would not bother to fix an issue that you might find while running a particular test, I would consider not running that test at all. Instead, invest the rest of your time in planning for failure. And here's some questions you could ask yourself just to get started. Is it possible to roll out our changes gradually? What information do we need to know that something's going wrong? How will we be notified if something is going wrong? Who's responsible for responding to notifications about errors? And what will we do when we get one of these notifications? Also, who needs to be kept in the loop about what we're doing while responding to an error notification? Are there cases where fixes or solutions to problems could be just executed automatically without intervention from us? What's the fastest way we could roll back to an earlier version? What are our contingency plans when something goes wrong with things that we depend on? I could continue adding to this list, but I think I'm just about out of time. So I'll remind you of the key piece of advice that I'm trying to offer today, and that is it's a good idea to be ready to handle failure because you probably won't find all the bugs anyways. And that's it for me. Feel free to reach out on Twitter or the Slack or wherever. Thanks for your attention.